Well, I'm back at it again. I couldn't leave this project alone. In the earlier video, I showed how I used a TE50A to, in a slightly different mode that I call DC transconductance, to do tube matching of some triodes, 6SN7s. And you see over here, these are the same 6SN7s, but a new tube tester. This is the earlier model of the Lafayette tube tester. This is called the TE15. And what I thought I would do is, since I have this earlier model and I also have a couple of the TE50As, I thought I would do exactly the same experiment that I was doing earlier, but also compare across all three to see if variations, for example, even in the same model, might make a difference in the readings you get, and also whether this earlier model might get a different reading than the later model. A couple of things I'm going to be doing in a little bit. I'm also going to be working on those 12AT7s over there and try a similar kind of thing. Those are three. The three on the left are Phillips 12AT7s. They claim to be JAN, Joint Army-Navy tubes, and then the two on the right, one of which you see coming out of its carton, and are two generic 12AT7s that are just marked China. So I thought I'd try those 5 tubes in a similar kind of thing. Once again, on the emission testers in the DC transconductance mode as I've defined it, and then also test them on the 707 and the 650. One reason that I'm doing this video isn't just because I'm obsessive, but also because there were some questions about whether, since I had modified the TE50A, at least one viewer asked, well, I'm not sure I want to modify my tube tester because that might mean I can't use it to test other tubes. Well, if I confused people, the only reason you need to modify the tester is if you want to try hooking up an oscilloscope and doing curve tracing. If you just want to replicate the results that I got of trying to use an emission tester but in a different mode, you don't need to modify it at all. And so let me show you that one of the reasons that I'm doing this is I'm just plugging this straight into the AC line over there. And so this is an unmodified TE15. When I get to the TE50s, the pair of them that I have, I'll show you that what I have done is I have unmodified the TE50A, gone back and repeated the experiments, and then done exactly the same thing with an original unmodified TE50A as well. So you don't need to modify these testers to do any of this. So let's move on now. I'm going to be doing those 4 12SN7s, and then I'll show you the results. And before I actually show you the results, I should explain a couple of things. One, I am still using the special position of the tester. That allows me to get the higher plate voltage. In other words, instead of using a tap on the transformer for the plate voltage, it uses the full plate voltage, or the full AC line voltage, to sweep the plate. The second thing is that you may notice I'm not using the isolation transformer. I'm just plugging straight into the AC line. Now, I always encourage everyone to use an isolation transformer, and lest I become known as the disciple of safety, or worse, the safety preacher, I encourage people to use that no matter what they're doing, whenever they're working on electronic equipment or any kind of equipment plugged into the AC line. But the reason that I am not using it now is to demonstrate that you don't need an isolation transformer to do these tests. Also, I point out that because What I was using was a variable isolation transformer. The actual line voltage that I was using, while it was consistent across all the tubes I tested, it was whatever I set on the that Syncor variable isolation transformer, which measured 117 volts. Well, my line voltage here is actually 122 volts. So the tests that I'm doing now are all done using 122 volts, or whatever the line voltage happens to be at the time I take the reading. Finally, so that you'll understand what I'm doing here, one thing that I will point out, and I apologize for the lack of parallax there, but you see the way that this meter reads. I am estimating, or I guess you would say interpolating might be a fancier word, but it still means estimating the readings. So, for example, this one, let me turn the camera a little here so that it's a little more along the line of the needle. And you see, I would estimate the line that's just above, that is just above the pointer, would be 72 and a half. The large black line below is 70. This large black line is 80, so the middle line would be 75. That would be 72.5. So I am estimating that at 72. And so when I write down the numbers, that's the way I get the numbers. I'm not trying to say, for example, if it was right on that middle line, it would officially be 72.5, but I'm not going there. The last digit on these things is not that important. It's just, I'm just looking for relative readings. So for example, that one reads about 72 in my estimation. If I now look at the other plate, that one to me looks like 74. And so that's what I wrote down. So here are the results. Before we look at this, I'll just point out that the testers that I'm using, the one on the left is the original TE50A that I modified by, the only modification that's still in this tester is I replaced the original cord with the polarized cord, as I pointed out in the first video, for safety reasons. It originally came with one of those gray cords like this that does not have a polarized plug. So I could have left it in the original condition for this, but because I was going to be connecting it up to the oscilloscope for those curve tracer trials, which you don't need to do for this, I decided to change the cord. Over on the far right is the TE15, and in the middle is the TE50A, which you may notice, in case I do some further experiments, I wrote a little number up here. This is TE50A2, whereas this one is TE50A1. So anyway, let's look at the results now. And if you watched the earlier video, you know that this column is the tube type, with the first two being those Sylvania tubes A and B, and tubes C and D are the Zenith tubes. And then the 1 means section 1, the 2 means section 2. These are the readings I got on the B&K 707 and on the B&K 650. Maybe at some point I'll go back and try something perhaps with a Hickok tester or some other mutual conductance tester. I have about 6 or 8 of those, so the possibilities are at least beyond most people's patience. So this is the TE50A number 1. In other words, the original 50A that I was using for the experiments in the first video. This is the second unit, and then this is the TE15. Well, without belaboring all of the differences, they aren't very many. Basically, the readings I got on the 50As were essentially the same. Notice this is a 76 and a 77. That could just be estimation error. 75, 76, 77. So in other words, it looks like, and by the way, I didn't look at what I was doing. I just wrote down what I just typed it in as I got it. So, for example, I had not realized that there's only one number that's different, and it's that one right there, where I wrote down a 76 instead of a 77, and this could have been a 77, or this could have been a 76. The idea is that the same basic idea is true. In other words, the tubes that the 707 and 650 said were relatively well matched, the TE50 used in this mode, that is using the plate to conduct current through the meter instead of the grid, seems to give a similar kind of indication. That is, the biggest mismatches are in the zenith tubes. Notice a difference of 3 here, difference of 3 here. Same on this one. The TE15 consistently gave slightly lower readings. That undoubtedly is due to perhaps the age of the unit. It's a very old unit. I think I bought this in the late 1950s. It is the original. So you notice that where these were reading 76, this read 74. Similarly, when this read 73, this read 71, and so on. But the basic differences look the same. In other words, the tubes that are relatively well matched are within 1. And once again, as I say, this can be just estimation error or the difference. Whereas the tubes that showed quite different on the mutual conductance testers showed much more difference using this DC conductance method. So, as I indicated at the beginning, I'm now going to repeat these experiments using a different tube at 12AT7, and then hopefully wrap up this, at least this video. The tester I'm going to use for the emission tester is the number 2, in other words, the unmodified TE50A, and then here are the tubes that I'm going to be working with, and you'll notice that the 3 on the left are labeled Jan Phillips 12AT7s. The 2 on the right are labeled 12AT7 China, and I bought these from 2 different vendors. The vendor on the left is a vendor I've used before. It's been a few years ago when I bought these, but nonetheless a reliable American supplier of new old stock tubes. The 2 on the right I bought on eBay from a vendor in China, so they are what they are, and we'll see how they wind up in the test results in terms of matching and so on. And now we're testing on the 707. So let's take a look at a couple of those. Test 1. I read that as about 66. And that is about 65. And I'm going to show this particular one because it's the tube that came out of that box right there, which is the one I have called tube D. So let me show you what it reads on the meter. Here's test 1. And I read that as about 62. Test 2, and I read that as about 53, maybe 52. And of course, this is the tube we've been comparing. And we're using pins 1 and 6, that is, the plates of the 2 twin triodes. And this is a high mu twin triode. And if you're interested in the characteristic curves, they're here. Notice that, once again, because we've been using zero grid bias on the TE50, that would be this curve here. And notice that this tube can take considerably more plate voltage than the 6SN7, and so the 160 or so volts that we're using on the TE50 puts it way down in this part of the characteristic curve. So that may or may not be a good comparison, but let's look at what the results are, and we'll see. Now, once again, without getting into a lot of detail, because we're just looking for relative figures here, this is the readings that I got off of the 707, that is the B&K 707 mutual conductance tester. Next to that are the transconductance readings I got off the 650. And once again, the last couple of digits are kind of estimates or guesstimates. And then the TE50A, and once again, the last digit is probably subject to some error. So what can we find out? Well, the first two tubes, A and B, are the ones that are labeled China. And you may notice that, in general, they are not as good as tubes C and E. But notice tube D, which is labeled a Jan Phillips 12AT7, is actually worse than the two China tubes. Not only is there a substantial difference between the two sections, but the overall gain of this tube, whether on the 707, on the 650, or on the TE50, shows that this is a marginal tube. And in fact, on the 650, this 3220 is very, very close to the questionable region on the tester. Similarly, on the 707, 52 is getting close to the questionable region. So what can we learn from this? Well, I think what we have shown is that while you aren't going to get quantitative measurements, and there's certainly no traceability to an NIST standard or anything like that, what you can say is, suppose you have a box of tubes. Suppose you have 5 12AT7s, like we have here, and you want to know, well, which two should I put in my amplifier? Well, I think what you can see is that you can actually put the two China tubes in. They are relatively close together, and the sections are relatively close to one another. Or you could put in tubes C and E from the Phillips set. Now, this, while all of these were advertised as new old stock and came from a relatively reliable, at least in the past, supplier, though I did buy them a couple of years ago, so maybe something has happened to tube D just sitting on the shelf, but it clearly is not as good as tube C or E. And similarly, if you're just trying to match sections, or you're trying to match a couple of tubes, this method of using a tester, an emission tester, in a kind of DC conductance mode, I think I would be willing to accept the results. In other words, if I were doing this for myself. Now, obviously, if you're a professional audio shop that does repairs and restorations, or you're a tube seller or whatever, then what you want is the absolute best tube tester you can get, maybe a curve tracer, maybe something like some of the laboratory grade triplet or Hickok testers that were made, something like that. But if you're just an ordinary individual with a box of tubes and trying to figure out how to match them in your tube amp, I think you can use a emission tester to do that. But before I close out, let me show you one little downside. This is a Mercury model 1101 tube tester. It's a rather simple emission type tester. However, the way that it's arranged, the circuit design, does not allow you to test the way that I've been testing using the TE50 or the TE15. The reason is that one of these switches is for selecting the filament, and the other two switches are for selecting the plate and the cathode, or as normal in most of these testers, the grid and the cathode. Because of that, there's no way to ground the grid at the same time that you switch in the plate. And without grounding the grid, you're going to have electrons collecting on the grid and making your measurements completely worthless. So this is an example of a tester that if you bought it blindly over the internet thinking, oh well, I'm going to use this great technique of DC conductance. And by the way, that's just an invented term. I'm just using that. I haven't been able to find a definition of DC conductance that there is a definition, but I'm not going to go there. It's not exactly what we're doing, but it's very similar to what we're doing. But nonetheless, if you were to buy one of these testers and then try to set it up the way we've been setting up the TE50, you wouldn't be able to do it. So you'd be very disappointed. Not that there's anything wrong with this tester. It's a perfectly good emission tester. But it will not do the kind of testing we're talking about here, simply because if you use the plate and the cathode, the electron flow through the tube is going to be affected by the space charge on the grid. And while I haven't tried it, I'm guessing that probably you will not be happy with the results. In other words, they probably will not track as well as the ones we got off the TE50 did with, say, a true mutual conductance tube tester. So, once again, I had expected to kind of end this after video 1, but some viewer questions and comments prompted me to do this video, which I hope you enjoyed as well. And like I say, I may not be able to do quite as many as I've been doing in the past, but I will try to get around to a video now and then. In the meantime, have a nice day.